Hello everyone, welcome back. Today is another level 5 SAT problem as part of our SAT level 5 problem video series. Here is the problem. This is a problem, geometry problem, where you have equilateral triangle ABC, ABC, and we have the area of our circle, which is centered at O. Area of circle is 9 pi, and I need to find I need to find the area of triangle ABC. Okay, so there are many approaches you could choose from to go ahead and solve this problem. So I will show you those 2 or 3 approaches. I would say 2 approach here. So let's start with the approach where you need to use the formula for equilateral triangle area. If you know that, this approach would be more convenient. So let's do that. So if you look at this figure, you have a circle, and sort of looks like this triangle is inscribed in this circle, but not. The triangle is not inside this circle, but one of the complete height of my triangle is the diameter of my circle. Somehow, if I find half of that diameter, which is my radius, which is this much, I can go somewhere. Okay, let's do that. So area of a circle is given as pi r square, which in my case is 9 pi, which is provided to us right here. So I want to isolate r square by itself because I want to find radius. So definitely I don't want that pi there. So divide it with both sides. Divide pi on both sides. This pi cancels out. You have r square and then 9. R square is 9, but that is not what I'm looking for. I'm looking for r by itself. So in this case, take radical. So that cancels out. And you would have r on this side and then 3 on that side. Okay? So radius is 3. So if this part is 3, this part is 6, because twice the radius is my diameter. So D, denoted for diameter, would be 6. So this is one of these concepts where you can use a triangle. Let me draw this part properly so they connect. Okay, so I have this triangle which is 90 degrees here, and look, this is a triangle ADB, this part, and I found this to be 6, right? Okay, so we know from the problem that triangle ABC was an equilateral triangle. So this angle, which is one of the 3 angles in my triangle, is 6 degrees, right? So this would be my 60 degrees. So somehow I can find this. If I find that, finding the area of my triangle will be much easier. So let's find that. So in my triangle, so since this is my angle of reference right here, this, let's say my opposite or perpendicular or A, whichever you want to note as. If that is A, this is my B. C being the hypotenuse, the longest side is always C. So I don't care about what C is or how much longer that C is. I don't need to know that. All I need to find is the value for my B right here. So I need to find a trigonometric expression which has A and which has B in it. And the only expression that I find is tangent. So if I use tangent, theta would be A over B. Opposite over hypotenuse. So opposite over hypotenuse, right? Okay, from your trigonometry class, if you have taken it or not, then this is the expression that you would use. So in my case, tangent 60 degrees is A and B. A I already know, which is 6, and B, which I don't, so I just write it as B. So let me write it one more time. Let me shrink it so you can see the whole part. B Okay, and this is what I suggest you guys to do it every time you have a fraction on one side, which is the equation, and then on the other side, which is not a fraction, make it look like a fraction, so it's easier. So both like terms, it's easier. You know, this is multiplying 1060 and b is multiplying as part of my cross multiplication, because every time you have a fraction a, b, c, d, a multiplies with d and b multiplies with c as of a cross multiplication. So you would have b times, let's not write that, so b times tangent 60 is equal to 6, right? But I want to isolate b by itself, so divide with tangent 60, and then this cancels out, b 6 over tangent 60. This part I could come from here to here directly and completely avoid doing this, but since this is a practice, I want to show you guys how do I get to this part, you know, the mechanics behind this algebra that I just used. So this is how I get it. So b is equal 6. And 1060, what is 1060? 1060 is radical 3. So you have b is 6 over radical 3. Okay? And I need to find the area of my triangle. So what is the area of a triangle? So let me draw a random triangle, which is this. Area of my triangle will be the height times base, 1/2 times height times base, right? 1/2 part of a formula. Height I already know. This is the height, which is 6. And base, this, if you multiply this with 2, you would get a complete base, because what I found for b is a half of it, which is half of this right here. So to find the whole thing, I need to multiply it by 2. So that would be 12. That will give me 12 over radical 3, right? And that's what I'm going to use here. Let me give you what I did. That is what I'm going to use here. So 12 over radical 3. Okay, so let's do that. Since I said if you have a fractions, make it look like a fractions, easy computations. Okay, so 2, 1, 2, 3, right? So 3 times 12, radical 3 over 1. And now you must be asking this question, like, why I'm doing all this, but why not just multiply 12 and 6 here first, you know, and then 2 radical 3. Yes, you could do that, but your objective is to eliminate much of the work, so you can utilize your work to, you know, help you solve this problem faster. And this is one of the approach. So if you have this format, you easily see this radical 3 in the denominator. This 3 can also be written as radical 3, right? If you multiply that radical 3 times radical 3, you will get back to 3. So I'm not doing anything. I didn't change anything. I just changed the way it looked because there was radical 3 here. So conveniently, I can get rid of this. And then let me write it here. And then you have 1 radical 3 is already gone, times 12, and there is nothing underneath, which is 1, but it's nothing. So 12 radical 3. So that is the area of my triangle using trigonometry concept, which is right here. But what if you don't know any of this? You don't even know tan theta equal a over b to start with. Then obviously you may not even know what 1060 is, right? And that is a roadblock. Obviously we can't use this tactics. So there is another way of doing this, which is a formula way. So let me do that here using formula. So if you have an equilateral triangle, and it may not be equilateral, but close enough. Let me do one more time. No, it's not working. Apologize for that. Let me redraw it again. Okay, so you know, A, B, C. Let's say I have A, B, C. This triangle is not triangle from here, just a random triangle. So equilateral triangle, meaning every side are equal in length. So if this side happens to be S in length, everything is S. And area of equilateral triangle is given as S squared radical 3 over 4. So S squared radical 3 over 4, all I need to do is replace that value of S. So how do I find value of S? Let's go back to my problem. And let me draw the triangle, the half of that triangle. So this is the triangle that I just drew, and guess what? This is 90, and this is 3. This is 60 degrees. And sorry. This is 60 degrees. Okay, now I can use another method. If you have this thing given to you, let's say for this to work, you need to have this. This is the part of a problem where if you have this part, let's say in my case, which I already found, so let me use that part anyways. So that would be 6 over radical 3, and then you can find hypotenuse, which would be 3 square plus, you know, 6 over radical 3 square, and whatever that you get would be your S. And you can go ahead and plug it into your S square, and you will get a value of 12 radical 3, which is right here. So I encourage you to go ahead and finish this portion as part of your exercise, and let me know how that works for you on a comment down below. Thank you for watching. Please don't forget to subscribe my channel for more videos to come as part of a SAT level 4, level 5 problems.